We will now have a panel discussion. Changes in forecasting global supply and demand in the ultra-long term and ensuring food security. This is the topic on which we'd like to see a discussion. Panelists and moderators are those that have presented earlier. We have, as moderator for the panel discussion, Dr. Miyuki Iyama, Program Director for Information at the International Research Institute for Agricultural Sciences. The floor is yours, madam.
Thank you. This is Iyama of JIRCAS. I'm very honored to chair this session with a distinguished panelist. If the time allows, we would like to take questions from the audience to the panelists later in this session. So those attending online, please enter your question in the Q&A box. And first, please let me introduce our commentator, Dr. Kiyoshi Takahashi. This is the Deputy Director, Social Systems Division, National Institute for Environmental Studies. He has been working on the evaluation of climate change impact on food system, and he has been also one of the external advisors to Dr. Furuya and Dr. Izumi's project. Dr. Takahashi, after listening to the keynote speeches of Dr. Meyer and Dr. Weavy, could you highlight what do you think are the most critical issues or uncertainties in forecasting the ultra-long-term impacts on global food supply and demand?
Thank you very much for the introduction. Nice to see you. And yes, I support that Dr. Meyer and Dr. Weavy will ask questions to Dr. Furuya and Dr. Izumi. So let me concentrate on putting my comments on you two, Dr. Meyer and Dr. Weavy. And first, okay, I really enjoyed each of the presentations today, and I've learned a lot. And I have several questions to each of you. And if I am not actually an expert of the food security so much, so I may ask some strange questions, but yes. First, to Dr. Meyer, I think one of the keywords in your presentation was the productivity progress or improvement of productivity. And for the previous several decades, it was the cause of the increase in output, agricultural output. And, but unfortunately, recently, global slowdown of that, productivity growth has been observed. And here I feel like understanding the background of the change in productivity. I mean, what to say? Of course, productivity increase itself must be a good thing, but there might be some external impacts or effects of the productivity increase or improvement. What I want to say is that, okay, yes, directly speaking, and R&D might be the basic, factor for accelerating the productivity, but some other things may be related with it, and that could be also the cause of the slowdown of the productivity in recent years. That's what I thought. And so what I want to ask to Dr. Meyer is that, side effect of potential side effect of the productivity increase. I mean, for increasing the yield of crops, yes, it would be important for us to make biggest efforts for increasing the productivity. But on the other hand, if we think about various other things on sustainability, in such a case, the efforts for the productivity increase may have some negative side impacts on various things, and inequality in the world, for example, or it may have some negative impacts on ecosystem. I'm not sure. But anyway, I'm interested in those things, and I thought that, those things could be also the cause of the recent slowdown of that productivity. So that's the question which I want to ask to Dr. Meyer. And Yes, let me also ask some questions to Dr. Weave as well. And yeah, I think projection is different from prediction. And for the projection of the future, I think the communication of uncertainty is quite crucial. And there should be various different types of uncertainty assumed or considered in the analysis. And I think the source of uncertainty will change in future. I mean, near term, the coming 10 years, there must be some dominant uncertainty in the projection. But if we think about the half a century later, then in such a case, the dominant source of uncertainty may be quite different. So I would like to ask about the dominant source of uncertainty in the projection of food security or hunger risk and those things which you talked. And so those are the questions which I wanted to ask to each of you. Thanks.
Dr. Meyer, could you answer? Yeah.
So first, I think it is a bit of an open question of whether this slowdown recently. I think we can look at both public and private sector investment, and perhaps it suggests that at certain periods of time, the ag sector attracts attention and attracts investment, and that does lead to improvements that lag. I think that recent slowdown in both public and private sector investments contributes to that lower pace of productive growth. Now, I'm optimistic. You say, well, are we taking productivity gains at the expense of sustainability? I think this is a really great question, but I'm quite optimistic in some of the technologies that I see on the horizon. Because I really do think that it is not possible to achieve our three goals without the application of technology. We say we need to achieve more affordable food, we need to have farmers make income, and it needs to be done in a sustainable way. And I think that there are technology examples out there that can do this. I think about high efficiency fertilizer applications. So we're going to use more targeted, more direct fertilizer applications. So we're going to use less volume of fertilizer to improve our output, but we're going to use technology to apply that fertilizer in a very specific way. When I was at work, the John Deere folks brought one of their new boom sprayers, large sprayers for applying herbicide on a field. Each spray nozzle had a camera. Each camera was operated by AI, identified the weed, and only sprayed the weed. Okay, so this is a situation where you get a productivity increase because you're using less inputs on a more effective weed control, and therefore I think technology reduces the cost for producers. Then that gets passed to consumers in cheaper food, and yet we're producing more with less application of things that we don't like pesticides. So I think that, yes, the pursuit of production at all costs is not sustainable, but doing it in a way through technology and increasing productivity is an answer to some of the problems that we're trying to address.
And thank you for the question on uncertainty. That's a critical aspect of anything looking forward into the future, whether you call it a prediction or a projection. And either way, we need to be very transparent about our assumptions. There are, broadly speaking, two sources of uncertainty in the projections that we do. And one of those is that different models can use the same inputs and result in different outcomes because they have different assumptions embedded in the model. The other source is that we just don't know, for example, which emissions pathway will be on in the future. We don't know how incomes will change. We don't know how people will respond to changes in income. The way we address that uncertainty is just by running lots of different scenarios. It's an approximation, but we ask the question, what if 1,000 different ways? What if we run a scenario? So we start with a reference scenario or a baseline scenario, and that's what I focused on today. But then we ask lots of what if questions. We say, what if climate grows or increases or changes more rapidly? What if income follows the pathway that we projected, in some countries, but not in other countries? What if we do invest more or change a policy? So we can't run 1,000 different scenarios for everything we do, so we try and isolate the things that are of most interest, either because they're likely to have a very big difference or because they're within the control of policymakers who are interested in saying, here are some options that are feasible for us to consider. What if we go to this extent or we go to the other extent? So we approximate the uncertainty in that way. And it's really important I didn't do a good job of it today because I was focused on our baseline projections, but it's really important to put some sort of band of uncertainty around that, simply to acknowledge the fact that we don't know all of these answers, but also to highlight what drives the differences in outcomes depending on different scenarios. Thanks for the question.
Thank you so much. Maybe then, yes, actually, Dr. Mayer suggesting that he's very much optimistic about technology to, to take care of trade-off between productivity and then the sustainability by looking at precision agriculture technology. And then Dr. Weave was saying that, yes, we can present a lot of scenarios and communication is a key. Now, we want to ask maybe, actually, Dr. Takahashi is ready to ask a question about also Dr. Izumi and then Dr. Furuya. Yes. No? Okay, then can I ask Dr. Seth and then Dr. Weave to ask questions and then comments on Dr. Izumi and Dr. Furuya's work in terms of the contextualizing the uncertainties and then also their assumption about the productivity growth or something like that?
Yeah, thank you for the opportunity. I do have a question for both of you, and I started asking that during the coffee break, but I would like to follow up on that. One of the very important assumptions you made had to do with the fertilization effect of increased carbon dioxide. So one impact of carbon dioxide or higher emissions is increases in temperature, changes in precipitation. But as you noted, it also affects photosynthesis differently for different crops. My question, and that's a very fundamental assumption, I mean, a reality that needs to be incorporated. I mean, that's the plants that go around us take in the carbon dioxide that we exhale, and we take in the oxygen that they produce, and that's a symbiotic relationship that needs to be captured. But I wonder, not just how does it differ between maize and soybeans on the one hand, rice and wheat on the other hand, but how is it related to other factors that might be subject to farmers' control? And for specifically, I mentioned soil moisture and soil fertility, because farmers in some regions are wealthy enough or have the resources to be able to control those through irrigation, through fertilizer application. Poorer farmers may not have the same ability to address those constraints. So can farmers in some regions benefit more from CO2 fertilization than farmers in other regions, or rich farmers versus poor farmers? Is that how can we capture that kind of constraint in our modeling?
So about fertilizer effect. So I think that C3 plants such as rice and wheat, these yields will increase by the high concentration of carbon dioxide. So that's we already show you the increase in the yield. So but the C3's soybeans, that is a little bit different. So I think it is related to the daylight time, daylight hours, I think. So in that case, the shape of the inverse U, that inverse U shape the graph, that is a narrower than other C3 crops. So in that case, the yield will decrease, up and decrease. So and C4 crop, the maize, in that case, the yield will decrease because the CO2 concentration is already high. So the C4 plants does not have the fertilizer effect. So the yield will decrease in future. I think so.
Yeah, thank you for the great question. The CO2 fertilization effect is one of the effects from elevated carbon dioxide of the air. So, and fertilization effect is especially the Rubisco functionality in the photosynthesis is limited by the nitrogen availability. So this strongly depends on the soil fertility. So I'm not exactly sure about this around this, but soil fertility may affect some part of the fertilization effect on the photosynthesis. That is one thing. And generally, the benefit of the elevated carbon dioxide concentration is found in the dry environment because of the improved water use efficiency. That is as a result of the elevated, how to say that, stomatal conductance. That is the exchange of the carbon dioxide and water from air to the leaf of the plant. So the benefit of the elevated carbon dioxide can be found in the dry environment, especially for the water. And related to this, so the evapotranspiration contribute to reduce the canopy temperature. That reduce the heat stress for the crops. So this also have implications for the adaptations and improved varieties. So at least these three related to the elevated carbon dioxide.
In response to that, maybe this is too simple of a question for you as a plant scientist, but when we think about corn or soybeans or wheat, you were talking about canopy temperature, and I think we were talking about days of growth and the push for the crop to develop too quickly. So when you think about this, when you think about corn and beans and wheat, what are the traits that we should be breeding for to give us the most adaptation? Is it drought tolerance? Is it shorter varieties? Is it shorter dates of growth? Is it shorter plants? Is it better temperature resilience? What do you think we should be breeding for to give us the most adaptation? When I get a chance to talk to a plant scientist, I take the opportunity.
Yeah, actually, I'm not a plant scientist. I'm just an agricultural meteorologist. But anyway, that is a great question. Now the frontier of the crop modeling, we are seeking collaboration. We are doing a collaboration between the plant physiologist and simulation modeling. So the breeders and the physiologists provide some insight. This feature of the specific variety have a more to lead to the more heat tolerant or more drought tolerant. So the crop simulation, crop modelers try to incorporate such information into the parameters of the crop model. So such to derive such a linkage between the genomics and the crop model parameters, one of frontier, scientific frontier at this moment. And using such a technologies, probably in the future, we can provide some insight which adaptation or which genomics would be more tolerant in the changing climate conditions.
Thank you so much. Dr. Meyer, do you want to add something?
No, I just, when I get a chance to talk to people about what are the constraints in growth, if it's temperature or drought, it helps me understand what we should be breeding for, what are the constraints. And so I think this kind of work is really helpful for us to plan ahead, not just say, what are varieties which exist today, but what do varieties need to look like in the future to give us the most adaptive potential. So I thank you for that.
Thank you so much. Dr. Keith? Yes. Sure.
May I ask a question of Dr. Meyer? Okay. So when I have an opportunity to talk to the chief economist, I have certain questions. One of those is we haven't really made a distinction between public investment in R&D and private investment in R&D. And I know there's been, you alluded to a shift in the balance, at least in the U.S. Do you see the private sector moving in certain, I mean, you mentioned, for example, John Deere and pesticide application, but in terms of varietal development, do you see trends that the private sector is moving forward on?
So I'm not sure I see, varietal changes are ongoing. I would argue when we look at yields within the United States, and again, I am not a plant scientist. I'm not a meteorologist either. So my amateur, yes, only an economist. My amateur meteorology would say that the weather has been quite variable in the U.S. over the last couple seasons, and yet we appear to have bred better for dry, at least over short periods of time, of resiliency to dry conditions. So I think the private sector has invested in trying to achieve yield stability. I thought you were going to go a slightly different direction with this, which is, you know, there is absolutely a role for public investment because the private sector clearly has to derive a profit from those practices, where there are broad benefits to public investment in R&D that are hard for a company to capture, but are absolutely helpful in both increasing productivity and resilience. So I think we have already seen some changes in breeding in order to add to yield stability. And so I get it. I think, but I think that we have both public investment, we have private investment needs. We need to, and I wanted to take an opportunity to emphasize this, we need to have policy which facilitates producers' ability to adapt as well, to use new technology and have policies that don't stand in their way of adaptation, whether that's private investment or public investment, and the producer's application of it. So I wanted to take an opportunity to say that too.
Thank you so much. It means like even this kind of economic model, we really need to understand the physiology of plants so that the message coming out of the scenario have clear message where the R&D should be to make our food system more adaptable and resilient. Maybe CO2 fertilizer effects, but I think today's Dr. Keith's impact model was showing that, you know, even Dr. Mayer's presentation also showing that the impact of the climate change will be different by crops and then regions. And then some of the areas may be not suitable for soybeans and wheat, but as a local crop. So we really need to think about in terms of the global food security. Thank you so much. Now I would like to ask the audience if you have the question to have this great opportunity to interact with the distinguished panelists. I haven't seen any question on the Q&A box from the online participants. So can I ask the floor if you have the very urgent questions? To first, maybe our President Koyama, and then next.
If you allow me to. Okay. So the main point showed by the result of ultra long-term outlook. One major point is the huge increase of food importation in Africa and in Asia, and huge increase exports from North America and Europe. But that level of huge amount cannot easily be transported. maybe we need some sort of infrastructure or some sort of also institutional things should be prepared before that occasion, you know, if it occurs really. So I'd like to ask Seth and Keith, if possible, what should we prepare before? Or maybe it gradually happens, not all of a sudden it happens, but for that kind of structural change in world trade. Because the population is almost certain to increase in Africa, in Asia. Okay, that is my question.
Thank you so much. Yes, because of the demographic changes, that the trade imbalances will be becoming even bigger. So aside from the crop investment in R&D on crop, maybe we need also physical infrastructure to allow the flow of goods. Do you have answers, Dr. Meyer?
Yeah, so I think it's a great question because it's something that I think we hinted at, but I didn't get a chance to talk about in my presentation because of my poor management of time. But I think that I think we need to make note that even now, trade is both a method of adaptation to climate extremes. Trade is a method of adjusting to this. You know, we see in Mexico they had a drought of corn, so they imported more corn from us. We had corn because we had a good crop. Trade is absolutely an adaptation here. So when we think about not just resiliency to climate fluctuations, but to populations. I think we've also seen over time a development in Northern Hemisphere and Southern Hemisphere. I think developments which are quite positive that trade can provide a smoothing effect here. We are never more than 6 months away from a soybean crop anywhere in the world now because of the rise of the South American crop. So you're right, we need to make sure we have ways to load that grain and ship that grain. I think the market probably functions the best way to figure out how to do this, when to do it, and in what volumes. And if it occurs over time, I have confidence that infrastructure, at least on the exporting side, will be sufficient. And we probably do need to worry about on the importing side for developing countries that they have an ability to receive that grain and that they have domestic policies which allow that grain to flow, right? So again, I think that it is good that you have raised trade because I think trade is a mechanism for adaptation in and of itself. And I think we've seen growth in trade, but it also reminds us that in the United States, you know, we expect that the U.S. will have to supply more. We also need to make sure we continue to be a reliable supplier. I see trade actions in other places in the world. Yesterday I talked about export controls out of India in terms of rice. These are things which are not helpful to food security around the world. So we need to both have trade, we need to have market transparency and information, and the exporters need to be reliable into the global market.
Yeah, I would just echo. I mean, it's an excellent question. In our analysis, we don't focus enough on the cost of these types of structural changes. We talk about the demand and supply balances and what that implies for trade flows, but without looking in sufficient detail at what it actually would take to realize those changes. I think you made an important distinction there in terms of where that infrastructure investment may come from and the differences between that happening on the exporting side versus the importing side. I think there is a tremendous gap and a challenge for improving that kind of infrastructure, which typically is publicly funded because it's a vast investment with a long-term sort of time horizon on it. And that's something that definitely needs more attention, including in our models. Right now we cover it in a very simple way, but not sufficiently. One information source that could be helpful, there's some really interesting work that's being done at the University of Oxford looking in very high resolution at transportation costs from any point in the world to any other point. And it varies by commodity, what type of transportation is needed to move different types of commodities, and also it breaks it down by different, by road, by rail, by shipping, and I think it has port infrastructure as well. Just data on what the current state of things is. I think that's an important source of being able to understand where some of those limitations are going to be binding constraints in the future and where we particularly need to focus investment.
Thank you so much. Maybe can I take another question?
Okay, thank you very much, Chair. Thank you very much for the sophisticated presentation from all speakers. Thank you very much. I have a question for Dr. Sesmeyer and Dr. Keith Weaves. So I think based on your presentation, I think the chief economist is a focal point to coordinate with technical and evidence-based analysis, and policy implication recommendation to, for example, Secretary of U.S. Department of Agriculture, Congress, and senators, and all stakeholders in the U.S. agricultural sectors. So, and IPRI is conducting the policy recommendation and implication based on the evidence-based analysis, mainly from the water impact model analysis and other analysis. And my question is, how can you narrow the gap between the academic sector and policy sector for analyzing climate change impact on the agricultural market, agricultural production market, and coping with future climate change? Like your school, Schoology, so the three stories, all the current and future stories. Thank you very much.
So I alluded to this a little bit in my comments, in that I think policy, especially in the United States, is outpacing our ability to properly measure these things. And so I am not a policy maker. I'm not even a policy suggester. I am a policy analyzer at the U.S. So my job is to say, this is how things work. And I think that we are making investments in my shop to better reflect and understand the implications of different farming practices on carbon sequestration, different patterns of practices or high efficiency fertilizer effects, all because we are establishing policies, whether it be biofuels or other factors that pay for performance. And as I said, if you're going to pay somebody different based upon their carbon intensity score, you better be able to measure it well. So we are investing in proper modeling and data keeping in order to provide better responses to policymakers to achieve the objectives that they want to achieve. I think it's a real challenge. I think when Keith talks about the uncertainties in his model, you'd always like to narrow those. And there's a lot of research and work and my colleagues attempting to narrow that. But when I'm advising policymakers, I can't say, well, the uncertainty is this big. I need to come down and think ahead on modeling and say, yeah, there are uncertainties, but here's the order of magnitude necessary, or this is the kind of policy action which will get you closer to where you want to be because this is the score. I hope that answers some of your question, but maybe Keith has a follow-up.
Yeah, well, just to add an IFPRI perspective, so in our name, food policy research, we're also not, by training, by disposition, we're researchers as opposed to advisors, but we're increasingly asked by our funders to make sure that our research is relevant to inform policymaking, not just an interesting scientific exercise. So two observations on that. First of all, the scale of analysis that I described using the impact model is broadly global and regional. I mean, it builds on more detailed analysis, but it's typically, we find it's most useful, or at least our partners find it's most useful for decision makers who are operating at that scale. And that's not usually national governments except for their funding agencies of international development. So it might be those funding agencies, it might be multilateral organizations who are making decisions about where they should focus. Should it be more on Southern Africa? Should it be more on Southeast Asia? Should it be more on staple food crops? Should it be more on fruits and vegetables? Those kinds of questions are things that we can inform with our analysis. But there's actually other analysis we do at IFPRI using country-level, economy-wide models, which is actually much more suited to engaging with national-level policymakers. And there too, that's done in two ways. One, it's through using those tools which can look much more specifically at, in a specific country context, what are your constraints, what are your policy objectives, what are the instruments that you have available for you, and then to do analysis that can help rank different options depending on those outcomes. It's the analysis, that's one form. The other one is by direct engagement with policy research institutes in those countries to share capacity, to work with them so that it's not an outside organization that's providing advice, but it's an outside organization that's helping build capacity in the country so that they can make better informed decisions themselves. So it's definitely, you know, very conscious of trying to channel research into useful forms for decision making at different scales.
Thank you so much. Now the time is approaching to the end. Do you have any other? Is Dr. Ismin? Okay.
Thank you, Chairman. So I would like to take this opportunity to ask the leading economic modelers here. So my question is about the reorganization of trade patterns, reorganization of the trading patterns. And so for instance, climate change, probably the Arctic sea ice will disappear depending on the warming in the future. So in that case, the transportation route would change in the northern hemispheres. So I'm curious about can current economic model consider such a change in the transportation route, or if not, somehow how can such a change be incorporated in the model? That is my question.
Yeah, by coincidence, we were just talking about that. Was it at lunch today? I think it started with recognition of trade bottlenecks in the Panama Canal, the Suez Canal, things that have already led to different changes in trading patterns, and then thinking about in the future, exactly as you said, reduction in sea ice around the North Pole and whether that might open new trading routes, which, by the way, have been a goal of exploration for how many hundreds of years, I don't know. They're looking for what we in the Northwest, or in the US, we call the Northwest Passage around North America. How do we do that in models? So far, I mean, different models do it better. Some are much more suited to trade. Impact, I didn't elaborate on this, but we look only at net trade, net exports, net imports to, quote, the global market. We don't actually analyze bilateral trade between specific partners. There are ways we can approximate that, and one way is that we have what we call marketing margins, which are effectively parameters that say how costly is it for you to participate in the global market. An even better approach would be models that specifically look at trade between individual partners, and they could then have a cost that might say, well, all of a sudden, this trade route that wasn't available in the past suddenly becomes available because it's now shorter or lower cost than a traditional route. That would be, certainly it's possible to capture those. I don't know of anyone who has specifically looked at that particular new trading option. I'm sure there are some that have. Yeah, we have not yet done that.
Well, and just really quick, I think about this maybe even a slightly different way, which is we do see quite a bit of market flexibility when it reorients. When we had, interesting, I thought we might go in a different direction in terms of we had trouble in the Panama Canal because of low rainfall in the region. So there are climate effects here on transportation on the negative as well too. Transportation costs tend to reorient trade somewhat. They are not a huge cost overall in terms of the product. They can be. But we also need to think about the other side of climate effects in terms of our ability to use canals, our ability, how climate affects our ability to use our load-out facilities or our port facilities on the import side as well too.
Thank you so much. Is there any other urgent questions to be asked, or we can have some after wrap up? We can just ask our distinguished speakers if you have very important questions to ask. Okay, please. Thank you so much, the panelists. Please let me wrap up briefly. Today, global food and then supply and demand are expected to tighten in the future, in the long term, driven by climatic and non-climatic drivers because of the demographic trends and income growth of the global south. And then it's with different impacts by crops and by regions. And then different, even the climate change have different impacts, the CO2 fertilization, then also extreme events and so many different issues. But anticipating different possibilities with the best of our data and the knowledge will guide us where to invest in, especially to not to deteriorate, just more maintain or improve efficiency of production, the total factor productivity. And some of the technology may be already available, like John Deere with this spray targeting each, the weeds or pests. But maybe this technology may be not available to global south. Also, we have to really looking at those from the justice point of view. But we really appreciate the efforts of the scientists and to improve the models and the knowledge, even incorporating the different, disciplinary knowledge like crop modeling and other fields, so that the economists can take advantage of these issues to improve the models. And we really appreciate the policymakers, especially ministries, this time Ministry of Agriculture and Forestry and Fishery, to open up this opportunity to allow the scientists to invest in this kind of model, and also having this kind of symposium to have a forum with even the public, so that we can really discuss what we are learning, and then where we should be improving. We learned today, we are talking about the global food supply and demand, but from the discussion with, participants, we really know we are not going to see only the global food demand and supply. The structure will change, trade will change. We have to be, we have to be very attentive all around. And then that is one of the major, achievement of today's symposium. Thank you so much. And then we really appreciate the distinguished panelists. And then thank you for the organizer for this very special event. Thank you so much.
It was a wonderful discussion. To those of you who asked questions, we'd like to thank you as well. Thank you very much for waiting. Ladies and gentlemen, the last part of the program, we have Mr. Umeshita Yukihiro, Counsellor Director of the Food Security Office of the Policy Planning Division of Minister Secretariat of MAFF, to deliver his closing remarks. The floor is yours, sir. Thank you very much for the kind introduction. My name is Umeshita Yukihiro, Counsellor Director from MAFF. In closing the International Symposium on Long-Term Impacts of Climate Change on Global Food and Supply Demand and Food Security, I'd like to say a few words. I'd like to thank all the experts from Japan and overseas who took the time to give us their valuable presentations despite their busy schedules. And for those who have participated in the panel discussions, I'd like to thank you for a very interesting discussion. As the experts have already presented, in the recent years, the situation surrounding has changed due to factors such as global climate change, population growth, rising food prices, economic development in emerging countries, and rising demand for biofuels, which have increased the risk to food security, among others. The situation surrounding Japanese agriculture is changing significantly. In response to these changes in social conditions, in May of this year, we revised the Basic Act on Food, Agriculture, and Rural Areas, which is the basis of the agricultural policy for the first time in 25 years. And we are currently in the process of formulating a new basic plan for food, agriculture, and rural areas. And in these studies, as a country that imports a large amount of agricultural products, it's extremely important for us to be able to predict future trends in global food supply and demand. I hope that the content presented by the speakers today can be used as valuable simulation results for the planning and formulation of medium to long-term food security policies. And today's symposium, I hope, would become a trigger for thinking about food security going forward. I'd like to thank those who have participated in this symposium. And with this, I'd like to conclude my opening remarks. Thank you very much indeed. Thank you very much to Mr. Umeshita. So with this, we conclude the International Symposium on Long-Term Impacts of Climate Change on Global Food Supply and Demand and Food Security. Thank you very much for staying with us for a long time. And we'd like to thank those who have participated over Zoom. When you leave, please make sure that you return your receivers at the reception desk. So please do not leave anything behind, and have a safe journey home.